Start. Chama o pessoal para ver, ok? Good morning. Okay, so now we will have as keynote speaker Bernardo Almada-Lobo. Bernardo is a full professor of industrial engineering and management at the Faculty of Engineering of University of Porto. Is co-founder and partner at LTP Labs, a business AI company. He is member of the board of trustees of the Belmiro Foundation, member of the Academy of Engineering, former board member of INESC and researcher at the MIT Sloan School of Management. He holds a Bachelor Engineering, a PhD, and habilitation in Industrial Engineering and Management. All from Faculty of Engineering at University of Porto. He completed the Advanced Management Program at INSEAD and the Mergers and Acquisitions at London Business School, Certified Analytics Professional, a CAP by Informs. His area of activity is business analytics and artificial intelligence. He researches, develops, and implements analytical models and methods to support decision-making, solving management problems across various domains, like manufacturing, consumer goods, retail, and transport, with a particular focus on operations management and the operations marketing interface. He has coordinated and participated in more than 300 development, consultancy, and research projects funded by private organizations, science agencies from several countries, the European Commission, and regional bodies. He has published more than 100 scientific articles, and he is co-author of the book Analytics Sandwich, Bringing People and Artificial Intelligence Together to Unlock Business Value. He has supervised more than 20 doctoral theses, so we are ready to receive Bernardo in his talk. Thank you very much. Thank you, Bernardo, for accepting to be the keynote of this conference. Thank you.
All right. Thank you very much for the nice words, for the invitation. I thought you were going to do some summarization with LLM of the bio I've shared with you, and it is really a great pleasure to be here at ICCSA. I'm not from computer science. I shall start with that. I'm from operations research. And actually, my field of expertise has to do with combinatorial optimization, mathematical programming-based heuristics. And I've started my career as a production planner in the process industry, glass container manufacturing. And I remember quite well at the time, I was really proud of a set of very complex lot sizing and scaling mathematical models, and then some approximate methods to be able to solve the problem. And at the same time, I also developed some really basic spreadsheet-based heuristics, static dispatching rules. You can imagine which one hold a long time, right? Unfortunately, the models that I was able to publish a few papers on it, they didn't succeed through time. And from that moment, I'm talking here about over 20 years ago, this gap between theory and practice has actually perturbed me, motivated me. And this is even more true when we look to optimization. right? Because when you look to predictive AI, predictive analytics, the change management hurdles issues are not that high. But when we look to optimization, to have the users adopting recommendations, this is something completely different. So I will try somehow to reflect with you about where are we today in the adoption of optimization, and how can we make use of this new technology around generative AI, agentic AI, not to replace the expert, don't worry, but really to be able to maximize the likelihood of success in this arena. So what has been motivating me is really, why not empowering every business decision with advanced analytics and AI? Nothing against the power of intuition experience of the teams. But the things that in a lot of different situations, we can really cross-fertilize the power of data sources, internal, external, the power of different type of analytical and AI models with the power of experience, intuition of the team. And how can actually we make the best out of the two? So somehow I will try to show you throughout this talk something around the theory of the practice and then the practice of the theory and how both of them, they glue together. I know that the majority here of people are people like myself. We are academics. We fight for new models, new developments, but we also try to see what is the impact of our research also from an economical and societal point of view. So when I'm talking about AI, and we are all fed up of hearing things about AI, we're always thinking about somehow having models, algorithms that are able to perform tasks that somehow require what we call human intelligence, whatever that means, right? So talks about planning, identification, learning, even creativity. So we're talking about machines that, given the goals defined by the human, this is important. The goals are still defined, the objective function is still defined by the human, and the goals might be maximize operational efficiency, maximize service level, minimize cost to serve, or also not related to P&L. It could be maximize well-being, try to achieve ESG goals, whatever. But the goals are defined by the human. The machine makes predictions, recommendations, or take decisions autonomously. This is what we talk about AI and AI. And the thing is that when you look to all the different technologies, everyone is really excited because of the agnostic domain of possibilities. So we are able to use it in different domains, from operations to sales to marketing, to support functions, human resources, finance, whatever, in a high number of different situations. But nevertheless, currently, we still have the feeling that we are not there, in the sense that the technology has evolved at a much faster pace than the organizations were able to adapt this technology. And it's interesting because the issue is not about technology. The issue is not about how efficient is the new algorithm that you are developing, or the way you are able to use computer vision and cross-fertilize it with a different model or algorithm. I'm not sure if you remember, because we are leading the World Cup, right? 2 years ago, we had here in Europe the Euro Championship, right? And the opening game, I'm not sure if you remember, it was Germany against Denmark. It was the championship was being organized by Germany. And the first goal was actually scored by the Danish players. And actually it was considered offside because of 40 meters away from the goal, there was a toe that was somehow highlighted by the VAR. Do we say VAR in English? The VAR technology. So who here believes that the goal, not the goal, that the player was offside? Just raise the arm. Was the player offside or not?
No, it's fine.
I'm not saying if the goal should be cancelled. Was the player offside or not? Did the VAR work? The technology, the VAR worked perfectly, right? Now, who believes that the goal should not have been cancelled because that little toe did not make any difference towards the goal? Right? So what are we missing here in terms of better decision. My goal here is really trying to do better decision making. What are we missing here? Because the technology worked perfectly. What are we missing here? Common sense. What else? Human presence. You have someone look at the VAR, right? In theory. More context. We have in a lot of different situations, we have ambiguous objectives. So these type of things are things that in terms of optimization and prescriptive analytics, this really, really hurts a lot the way we adopt this type of models and algorithms. So it has nothing to do with technology. We love technology. You love technology. It has nothing to do with it. Now, if we look back to what we have been doing, we have been able, with computer science lands, with operations research lands, with different type of somehow research arms, we have been able to, throughout the years, throughout time, to sophisticate each time better the way we detect patterns, right? So we are somehow analyzing huge amounts of data from different sources. And this sophistication of the pattern detection has allowed us to be much better in the way we model consumer behavior, just based on past habits of our consumer. We have been able actually to be able to understand in operations management, what are the different factors that are somehow mining the operational efficiency of my operating theater, for instance. In terms of the uncertainty, try to model uncertainties, try to understand all the vulnerabilities that might appear at operating theater. We might actually, just by doing better detecting of patterns and then doing some sophisticated modeling, we have been able to do much better production planning. And also trying to integrate everything and do supply chain planning by integrating predictive and prescriptive analytics. So we have been doing this in terms of the research point of view, in terms of models and algorithms for years now. But nevertheless, when you look to companies, when you look to the way an operating theater today is still managed, believe me, a lot of manual decision making. Currently, the way we're actually trying to understand what is the impact of the tariffs, Trump tariffs, across lead times, across cost to serve, and so on. In a lot of situations, companies still use spreadsheet to analyze this type of factors. But honestly, we know what we have to do. So if you think about, for instance, the way we model clients' behavior, it could be B2B, B2C. We know exactly that we need to understand the life cycle of my customer. We need to understand what are the different KPIs, descriptive AI, that I want to monitor. And then how can I predict lifetime value, churn, the probability of losing the customer, the loyalty of my customer, and then also to prescribe things. What is the next best action, the next best offer? What is the best price? Shall I do cross-selling, upselling? We know this, but still, without just looking at retail, in the other sectors, we are not still there. The way we do pricing, if you look to pricing in B2B companies, it could be companies from industry to different sectors, they still do cost plus. So you have the total cost of ownership, you put a margin, goal, and then you have the price. This, you are destroying value. Why not really trying to understand what are the different features, attributes that somehow give us the value-based pricing? How much in that particular moment is my customer willing to pay, given the attributes of my customer, the attributes of my product, the attributes of the landscape of competition, my historical relation with my customer. And why not using predictive analytics to do elasticity-based curves and then having an optimization on top to prescribe prices? Why am I not doing that? We know for years that we could use in process variables optimization in industry, we could somehow optimize temperature, speed, cooling, pressure. Why are we still, in a lot of different plants, we still have the shift director, when he enters the new shift, adjusting slightly the parameters? Because we know that we can actually very easily come up with ML type of techniques and algorithms just to really be able to parameterize automatically the parameters. And this has a huge influence then in OEE, overall equipment efficiency, to maximize throughput, right? We know that. And we have been doing a lot of research on that, but we're not able to convert that in innovation. What I've been doing in my research around optimizing sales and operations planning in different types of industry. So sales and operations planning, I'm talking about here a midterm capacity planning of trying to analyze the different lines, the different plans, the expectations in terms of sales, and how can I integrate that in a master capacity planning. I mean, the issue is not about the way we've been able to model this mathematically, trying to minimize setup costs, production costs, warehousing costs, trying to maximize service level, and then trying to decompose these or hybridize it with approximate methods. That's not the issue. The issue is that we've been actually focused in what we do, assessed by trying to have the best possible algorithm that runs. If it's not able to prove optimality, it's going to have running times that are really, really competitive, right? This is what we have been doing in research, right? But then the thing is that this is not enough then to go to practice, because what we have been seeing is that only 3% of the companies, I'm saying company/functions, are using prescriptive AI to decide the courses of action. Which decisions shall I make? So nothing against prescriptive AI, everyone is using diagnostic, but then when we move to more advanced type of AI, we have a huge adoption gap. And let me know how many times when you were working with some kind of partner, even if you're doing research, how many times you feel that what you're going to see in this video has happened to you?
Peter, come take a look at this. Look at this. The numbers, they keep getting bigger and bigger.
Clicks are off the charts.
Yoshi, Swamp, we're back.
I'll get you all three.
Take a look at what Paul.
Everything you got to right now.
He really loves something.
We are laughing, but I cannot imagine the number of times that we as experts need to rerun the models just to figure out what's going on there with a certain outlier, a certain King Kong data point that is really perturbing. So why optimization hasn't gone mainstream? That's the point, right? And this is regardless of the geography, regardless of the size of company. Optimization is still not there. The missing layer had actually to do with this usability, being explainable, interactive. But let me give you here some a little bit more insight. So the first thing is that this optimization adoption gap, it really depends the optimization potential about how fragmented the data is. How am I able today to understand what is the starting point of the operations or of the KPIs of my company? So do we really trust current business state? Whenever we are actually doing some model and doing some research, we often somehow assume a certain given starting point of the state, right? But the issue is that you might have here some latency, you might have here some issue around, do we really trust, where do we start? And this is important, especially if you're doing operational type of decision making. Then, how are we able to interpret things? And now, when I'm saying interpret here, I'm not talking about the interpretability of predictive analytics, that we try to understand what was the impact of an input X in the output Y. This is not that. I mean, interpretability here means in optimization, which constraints are binding? What is the shadow price of something? What is the reduced cost of a certain decision variable? Which ones are really dictating the way the decision is being generated? Interactivity. All of a sudden, what happens is that you have a rush order. You have a certain demand peak. You have a certain uncertainty. The lead time of your supplier went up and the supplier reliability went down. All of a sudden, you need to have a much better way of interacting with the user. And then the way you improvise, because your model, the model, sometimes is close enough, is a closed form. So it really suits you are optimally solving the wrong problem, because the conditions will then change over time. And we have also an issue around the way we adapt our models. But we went from a situation, if you think that we were somehow in the last, in terms of ML in the last 20, 30 years, but in terms of optimization, the last 50, 60 years. But then we went from a situation where we were able to somehow detect patterns, and then moving to neural networks and reinforcement learning, we were able then to start generating patterns, right? In terms of technology, underlying technologies was a linear evolution, but actually it exploded late 2022 because of a very easy way of interacting with any type of user, non-expert user. And then all of a sudden, and you'll see where I want to get to, the point of being able to generate text, generate code based on text, generate text based on code, image based on text, and the other way around. All of a sudden, this multi-source, multi-output of generative AI has allowed us to somehow mitigate part of the hurdles I was talking about in terms of optimization adoption. Now, even before going to prescriptive optimization, the way that we are currently generating patterns allow us to really revolutionize, for instance, marketing. We do not need, if you want to launch a new product, or if you want to understand what is the impact of a new type of service in a certain channel or in a certain geography, you do not need anymore to rely on historical data or to do some customer focus. You can actually just develop synthetic personas where you actually then are able, based on the different attributes, these are AI people, right? That you are able to somehow simulate what is the impact of different things that you want to assess. So this is a huge revolution, because then all of a sudden you are able to really reduce the time to market of different things that you are able to do. Now, the thing that when you start hybridizing generative AI with analytical AI, predictive and prescriptive AI, then the potential really blows up. Think, for instance, I'm not sure how many of you are trying to model the propensity of a certain customer to churn, meaning what is the probability of someone to churn your customer basis. Or you can use actually with the same type of technology, what is the probability of each one of you leaving your company in the next half a year. It's exactly the same type of thing. But so to this type of challenges, what you used to do is to go to a CRM to look to all the different RFM attributes, recency, frequency, so transactional data. And then now based on all the different interactions with the customer, mails, voice, claims, whatever, we are able to enlarge the data inputs significantly. So we are able to convert unstructured data into structured data. We enlarge the data inputs. Then we come up with our predictive analytics, predictive AI engine, just to somehow measure or predict the propensity to churn. And then the way I will try to engage with a customer, in case I believe that there is a high probability of churn, this again can be delivered in a very customized, hyper-personalization way. Let me give you here an example that I was involved with. This is a car retailer, and we try to do the following. Why not, whenever we take our car, our vehicle to maintenance, Why not in that point in time try to sell the customer a new car? So we are not with that mindset, right? We just want to get our car through inspection or through. But what we have there is that based on the client history, the attributes, and so on, we try to figure out what is the propensity of this customer for a new car. And then we have this matching algorithm that try classification, try to understand which vehicle could we propose to this type of customer. And then automatically, while you are just giving the key of your car, the system is going to tell you what, in kind of a savings framework, what is the added value of changing the car in terms of cost of usage of the car, in terms of the value, and so on. And then you have a sales script. So the salesperson that is there receiving you for the maintenance is going to give you a pitch tailored for you. Your customer has a 7-year-old vehicle, ideal opportunity to upgrade, blah, 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 blah. Actually, we sold the car the other day with this type of technology. But this is actually, all of a sudden, this is really being a game changer because no one was selling cars in the maintenance and inspection, right? So all of a sudden you are able to do. Why not also trying to somehow give a new life to our digital twins? I'm not sure how many of you here are doing digital twins to simulate something, but one of the things that when we're doing digital twins is really how do we create scenarios then to simulate. And instead of using manually these scenarios, so typically companies do a pessimist scenario, a realistic scenario, optimistic scenario. Why not having generative AI just trying to perturb and create different type of scenarios and then automatically linking to the digital twins? Now, these different ways of blending Gen AI and analytical AI really depends whether we are having a predictive case study or a prescriptive case study. But then all of a sudden, we are able with Gen AI to enlarge data inputs, as I told you, to interact better with the user or with our output clients. In the prescriptive, to really being able to grasp the model mechanics and to understand the model results. But then we were still trying to figure out what to do with Gen AI. And then all of a sudden, now we only hear about Agentic AI, right? We have been using agents to do a lot of individual performance tasks. Hopefully you are already using these in Claude or in Gemini or in ChatGPT. But essentially what we have here with the intelligent workflow optimization, linking these with LLM capabilities, now we have agent that is somehow a virtual employee that is able to autonomously plan and complete tasks. So we're talking here about a virtual assistant that is able to sense, what I mean by sense, to monitor the KPIs, to really understand in real time the KPIs, to plan, to drive different courses of action, to execute the plan, and then to close the loop, the feedback, to try to understand based on the plan that I have executed, what is the added value of this and how can I adapt my behavior. And actually this, to give you here an example, for predictive maintenance in manufacturing, imagine I have an agent, and this is not rocket science, this is already in place. So I have an agent that the only thing that it does, it tries to monitor all the different sensor data to somehow track vibrations, temperature, and wear, with the end goal of trying to minimize downtime, to increase the availability of my industrial assets. And then based on this monitoring of these KPIs, and also in some predictability capabilities, there is a generation of action. It is going to generate some recommendation. The vibration pattern suggests that you should do a certain replacement in a bearing within the next 72 hours, right? But then it doesn't stop here. What you'll do then is that based on what has happened, based on the outcome of this maintenance policy, this positive reinforcement learning, it will somehow try to understand what was the association between the new vibration patterns and the bearing wine that I have somehow replaced. Can I update then my memory so that next time I'm able to anticipate or not, or postpone or not, this type of recommendation? And this is done in cycles automatically in different ways without here any human in the loop. In a lot of different situations, actually, we have the human in the loop. In some situations, we do not have the human in the loop. Think about currently the way we recruit people. I'm not sure if each one of you has already been involved in recruitment with Agentic AI, but currently the way we do it is that we have an agent, hiring request agent, that is going to understand, based on the evolution and trend of the business, based on the rotation of people in key places, what is the likelihood of needing people in the next X months, and also based on how difficult it is to recruit a computer scientist, how much time do I need to do that in advance? So, and this hiring required agent is going to also define the package, the hiring package, the conditions, the reimbursement, and so on, and also the description of the function. And then this goes to a human validator that is going to validate, and then it's going to send again to another agent that is going to post the job in different type of platforms, and also creates the interview script and so on and so forth, receives all the proposals, select the 5 best ones, and then goes to a human interviewer. Well, the human interviewer is actually then selecting the one that is going to that position, and then again you have a communication agent to do the rest, right? This is happening in all different business functions. We want to know whether, and also in research and education, we want to know who is feeding us. Is it an agent or a human? Who are we feeding to? An agent or a human? So this actually will be our daily lives. And actually, in sooner, our chief will be an agent, which from an ethical perspective, this points other type of concerns. Now, I was just showing you that with this agentic AI, generative AI type of capabilities and analytical AI, with some process re-engineering, we are able really to integrate the best out of the two worlds. And this is what has been happening with prescriptive AI. With prescriptive AI, what is happening is that Gen AI is actually currently allowing us to be an enabler of the whole value ladder. So we are able with Gen AI to really, finally, to really take the best out of prescriptive AI, as I will show you. And this will be fundamental to make sure that we have data-driven organizations in place. Now, a couple of things that are important for this vision. The first is that your AI, your prescriptive AI, your optimization models and algorithms, they should be adjusted to the decision we need to take. If it's not adjusted, believe me, this is not going to work. What type of decisions are we talking about? Some of the decisions, I call it narrow decisions, very well structured decisions. So those of you that are dealing with maintenance, management policies, demand forecasting, routing capacity, fraud detection, you name it. These type of problems are problems that the objectives are clear, there's no trade-offs, usable data. So here in this type of situation, you can actually model very explicitly the underlying optimization problem. You can solve it. So AI in this situation should be really the engine to do the decision, predicting, optimizing, and recommending. In other situations, I call it wide decisions. Be careful because the goals are ambiguous, multiple criteria, trade-offs are not clear, alignment matters between the different stakeholders that you are involved. So things like brand repositioning, market entry, new product introduction, regulatory choice, and so on. Don't try to have all the party being done by AI. AI in this situation should, at most, should help synthesizing input, surfacing assumption, really trying to frame frame scenarios. This is the first thing I want to share. The second thing is that before Gen AI, what did we have? We have business user and then asking questions. We had our people like us, experts, data scientists, data engineers, computational scientists, that were going to dig into the model to answer those questions. Then they would do the analysis into our technology. And then based on this situation, we'll go back and we'll try to give the answers to the business users. And believe me, the business users are not stupid, right? So imagine that I'm doing a rolling planning forecast. And I'm doing this for the next 12 weeks in a rolling horizon scheme. So every week I'm doing again, I'm doing redoing the forecast. How can you explain to a planner that the forecast that you have done for week 3 is going to change twice as you are doing this planning horizon scheme? How can you do that? Doing production planning, all of a sudden, how can you actually then try to convince the planner that you are not using all the capacity of line X because you're minimizing the overall cost, and it says that idleness is better. But the guy is used to use always the capacity because of unpredictable demand that might appear in the future, right? So what happens is that this type of thing that we had pre-Gen AI process, what we had, very long planning cycle based on experience. People like us, we were doing things that we were really not proud of. It was really, really annoying. Just go, rerun again, isolate the constraints, try to understand what was going on, and so on and so forth. And actually, because of these manual iterations, the decision-making, even though we were using very complex mathematical models, it was a manual decision process, right? We were going back and forth, and then all of a sudden, there was a trust issue going on, and then the planners would resort to spreadsheets again and to some very basic rules of thumb, right? Low trust, low adoption. And this is actually has been this up to 2022. This is what we used to do. Edit the model, edit the parameter, rerun the solver, wait, compare results, and so on and so forth. Now, the thing is that in practice, even though we are completely focused in optimality, in practice sometimes has nothing to do with optimality. Sometimes the issue is really about feasibility. How can I really come up with a feasible plan? Are all my constraints being satisfied, being modeled? Is it a hard constraint, a soft constraint? And when we model, when we try to come up with a mathematical optimization, we have to have some objective function, right? Do you believe that the user, the business user, understand this type of trains? I call these trains, right? These expressions that we then all of a sudden, people like us, we do believe that we can convert a multi-objective optimization problem in a single objective optimization problem just to do by some normalization around some parameters. And we believe that, okay, it's okay. And then we beat the benchmark literature instances. But really, does the business user know the real costs? Every time has been explored these trade-offs between the different type of costs? How to assess the planning? You cannot imagine the number of times when I'm comparing the new plan with the old plan, they are trying to compare, but they have habits. They have habits, and if they do not see their plan, the thing that they are used to, they will lack trust. They are not going to adopt. And if they're not going to adopt, we are wasting our time, because what will happen is that they will resort to manual decision making. Now, we had this pre-Gen AI, but then all of a sudden, we were able to replace this guy here, us. How? Based on LLMs. Now, what happens is that all of a sudden, we have the business user asking questions, narrative with the natural language scheme, asking questions. Then we convert the natural language into coding. It goes through our solvers, obtain a new solution. The results are then converted within back to the LLM, and then converts this in narrative, in natural language for the business user. This allows fast decision making, right? So all of a sudden I have the business user. Why are we using supplier A for demand B? So I have an SNOP type of solution. Why do we have this? So then LLM is going to translate this into a constraint to our model. Then afterwards we solve it, and the model is going to minimize a certain function. It tells you, okay, that for that scenario is $2,760, and then it's going to give back in a narrative way for the business user. If supplier A is not used for demand B, cost rises 11.7%. All of a sudden, I do not need to interact with the data scientist, with the computational guy there in the middle, right? So this is actually been then motivating different type of frameworks. If you look in terms of research papers from this year, late 25, a high number of different frameworks have been proposed to have the best interaction between LLMs, Agentic AI, and optimization solvers. So you have different type of agents. So you have frameworks where from a description of the problem, you have the math agent that is going to convert this narrative in a mathematical formulation. That then have the code agent that is going to convert the mathematical formulation into an executable code. And then you have debugging agent that is just going and will try to somehow understand what are the inconsistencies, where do infeasibilities come from, and so on and so forth. Other people have been trying to understand when you move to irreducible infeasible sets, what are the constraints that are really binding or making my problem infeasible? And we're doing this by really trying to have this dynamic solver in the loop with self-correction. So a high number of people are doing that. We do know that if you just use ChatGPT or even ChatGPT with Gurobi and so on, just to model things, you have a lot of limitations still to deal with. But a high number of different frameworks with contextual and business layers and domain are actually now working much, much better. So we can focus on our mathematical formulations and models. And if you want your model then to go live, everything that may happen around demand spike, supply demand, if then all of a sudden you want to change the orientation of the company from cost first to service first and so on. I mean, these type of things will allow you to explore scenarios, compare plans, explain the results, adapt, giving trust to the users. Now, regardless of the underlying mathematical integer programming, regardless of the solvers of the schedules, you ask, you interpret, it adapts, it resolves in a very fast way. And you can do this for optimization models in trying different capacity. Use it also in predictive and forecasting and also in simulation. And another thing that is quite interesting is that it's kind of model agnostic, the technology that we have for this. So that means that you just need to bring a certain business domain layer for a certain application, and then the rest comes for free because you have this in a very easy way, and more important, an easy way, auditable way. You got my idea. Now, just a very thin business domain layer, and then you're actually able to have the orchestration around agents, the scenarios, and so on. Of course, then you have different type of implementations. You have different agents that will allow to do this orchestration and routing the conversation. But at the very end, after this is done, you are really able to understand, to shape, to investigate, and then to explain in a very, very easy way that you, as a computational scientist, you actually then understand, right? So the things that we are able now to do with trying to hybridize and trying to bring this domain model into a conversation is really, really something that is being changing the adoption of this type of technology in practice, right? Then the art is really trying to understand and to anticipate which type of questions and challenges can our business user pose, and thus actually our architecture allow for that. Now, let me show you here just an example that all of a sudden, if you have here a certain base plan, and then you want to somehow understand if I add new shifts to my base plan, what will happen? And actually, this is done in a very easy way. So I'll call the domain agent, the translator, all the domains are called, all the different agents are called in sequence. Then I have what is the output, what is the impact in a very straightforward way. This in terms of reliability, in terms of validation is quite interesting. Or if you want, then all of a sudden, if you want to somehow understand what are the different strategies that you might use. So I want to compare a base plan with two different strategies, protect cost, and then another one that is going to protect service level. This is going to be done quite fast, right? So my point is just that Gen AI, when I say Gen AI, let's put it this overall umbrella, which with Agentic AI and so on, is really bridging, is really bringing the gap between the users and optimization models to a very low level. We are actually being able, for the first time, to democratize mathematical optimization. Instead of being something just for 0.0001% of the world population, it's much easier now to use it. So you have a language model that will assist you in formulating the problem, proposing modifications, explaining the results in natural language, and then you have optimization solver that will verify feasibility, compute the bounds, provide the certificates, and so on and so forth. Now, we are trying to do this in every possible situation. People have been trying to do this also in robust optimization, in adaptive optimization. And sometimes actually it's interesting because, for instance, in Bert Siemens here in this paper, is still being reviewed, is actually able to, for a very simple robust optimization problems, it works quite well. If you do the correct prompting, if you actually then really try to understand how you can, actually it even generates code to solve the resulting robust counterpart. So it's actually quite interesting, this type of results. But on the other hand, in the same paper, Bert Siemens say, be careful, a huge number of limitations still, in terms of lack of consistency of the produced results. It has a lot of hurdles in terms of manipulating algebraic expressions and also applying mathematical theorems. Sometimes it doesn't apply the correct theorem, which then is going to pose huge problems. Now, my point, just to finish, is that this type of democratization of optimization is not only happening in practice. Also, we should also think in our research, what shall we do now in the way we are somehow deriving our research avenues? And we really should think how this, because Gen AI, together with optimization, together with algorithmic development, is really bringing a high number of opportunities that are going to somehow impact the way we do research and the way we actually being able to make impact in companies and ultimately in society. Thank you very much for your attention.
Okay, thank you very much, Bernardo, for your interesting and amazing talk. Now we open for some questions. Anyone?
Over there.
Thank you for this very inspiring talk. When you speak about this interaction between optimization and the user and using generative AI in the middle, we know that some optimization models are very hard to solve, and sometimes they require days to be solved. So how do you cope with this? Because I mentioned that the user doesn't want to wait 2 days to get an answer. So my question is, how
No, very interesting. Thank you very much for the question. Just a preliminary statement. I did not show to you any example where the Gen AI was proposing a new way of solving the problem. Right? I was always trying to do this interface because I do believe that the answer for that still comes from our communities. How are we able to make faster, more efficient algorithms to solve the problems? Now, having said that, whenever you have somehow an algorithm that, and I'm talking, I can imagine that it's kind of an improvement-based algorithm where you are systematically improving, so you generate thousands of solutions up to a certain point, right? In the algorithm that you were suggesting, you need to align expectations, right? If you have an algorithm that is going to run for 3 hours, it's not going to work, this interaction, because you want to somehow promote fast interaction between the user and the algorithm. Nevertheless, in a high number of situations, the user are just going to somehow ask a certain change modification in the underlying problem. So that means that you do not need to solve from scratch the problem. If you add a certain constraint, if all of a sudden change some coefficient of a certain variable or of a certain constraint, you actually can speed up by just trying to reuse the optimal solution that you had before, and then you can somehow try to see how you can get that solution feasible just by trying to solve a new algorithm on that scope. So my point is that the expectation should be completely aligned. If it takes hours, it's not going to work. You don't need to solve from scratch in a high majority of the situations, even though you might not prove optimality. The way I was saying, we have an optimality issue, but in practice, this optimal concept doesn't really exist. What is an optimal solution for the business planner where you have conflicting goals and you have a high number of uncertainties coming back and forth? Even if you use stochastic optimization, robust optimization, what is the notion of optimum? So just to tell that you can have very good feasible solutions by doing faster adjustment to underlying optimal solution of previous iterations. Otherwise, please don't do this interaction, it won't work.
Okay, thank you. Thank you. As I understand, these are the generative AI and the optimization, they are complementary.
Yeah.
Yes, they can help each other, but we cannot substitute the optimization models. Do you think we need to improve the optimization methods that we have, improve or create new ones, or we can use the ones that...
It depends on how intricate is the problem and how complex the problem is. This type of situation of trying to generate in few seconds from scratch a solution, there is always a room to really try to propose new algorithms. And even people, what we have been doing also in research, trying to hybridize reinforcement learning with mathematical programming based type of heuristic. There is always room in terms of research for that purpose. So I think always that research there's a really clear game to play. The only thing that we should understand is that some of us, sometimes we go away from trying to implement or kind of having a proof of concept if application A or B. Now with this type of translator, we do not need to waste our time and our brains just interacting with the user around a certain thing, because that comes for free in the future. So then we can actually focus on where our IQ, the opportunity cost is better, right?
I have just one question. We are almost all researchers. So we spend like 20 years, 10 years on a research topic, trying to, of course, implement in some part our structure, our architecture that we build in entire life. Nowadays, we are maybe, I don't know, we are in front of on another way of thinking, another way to approach to solve problems, and so it's a kind of shift in another chain of thoughts, no, the way of thinking. So my question is just provocative in this sense. So how do you imagine that this kind of chain of thought shifting would happen? Not only in terms of optimization, of course, and agent decision making, but in a sense how this researcher could easily shift from this structure set of mind to another chain of thought.
Well, probably it was not clear from my presentation, but I'm also a researcher. Just go to my Google Scholar, you'll see what I mean. Let's look to the positive side here. We can be much more efficient the way we do research. A high number of things takes a lot of time, and we are going to reduce somehow the time to do everything, from the way we synthesize data, the way we validate, the way we find inconsistencies in our algorithm, in our code. So it's the number of things that you can actually currently employ will allow you to, for the same amount of time, to raise a higher number of hypotheses, research hypotheses. So the first thing I would advise, honestly, is that if you feel that you are doing something non-added value from a research point of view, that means that there is something out there that can actually replace you on that. And this is the first thing, so that then we can then focus on really what is out there. Now, in terms of research, there is also something that changed in the last 5 years. We were 5-10 years. We were somehow, if you think about, for instance, the beginning of machine learning and then so on, from Canada, Toronto teams and so on, we were used to have the research coming from universities, research institutions, and then going through all the knowledge value chain up to the market innovation and so on. And currently, we had huge organizations, tech companies that have huge research teams that are doing research, that are also fit following us. So they are influencing the research community, the traditional research communities, in a way I haven't seen before. So we need to, honestly, to approach the communities, because we have always this feeling that they are just there trying to solve problem A or B, but that's not the case. If you go to Meta, if you go to Amazon research teams and so on and so forth, they have people there that are not linked to the short-term problem. They are really trying to understand what will be the new wave. So we really need to understand what is going on that. You're going to see something also that is a blending of different research communities, which actually I like here in this conference, because you already have, by design, this blend, right? So you have people from different. This is what will happen now. The head of operations researcher, computational scientists, is going to be blurred. You're going to need everything simultaneously all together. But it will change dramatically, and we need to still be useful in terms of, as a researcher. And this is an issue. I mean, it's an open question. I don't know. I don't have an answer for. Sorry.
Okay, another question will be the last one.
Takeshi Honto from Kyoto University. Very impressive lecture. And I agree with you that the democratization of optimization is deliver huge benefit to society. But I also think that it is important or useful for users to know that the optimization is behind Gen AI, and user can know that some program, optimization program, are very time consuming, or they are multiple minima. So I think it's education would be very important.
I agree, which is an issue because we are getting used to have from a click to have everything, right? All the answers and so on. And with these translators, we might give the wrong impression that the problems will be also solved by a click instantaneously. And we have an issue. We have an issue there.
I think I'm very good at upsetting AI.
Thank you for your inspiring presentation. And I would like to go to the gap, to the adoption gap that exists previously before AI. And in European Union, we have one document that is the AI Act, and it was developed or coordinated by a Portuguese person, Maria Tomás. And there are several issues there. One is interpretability, and the other is, which is more complicated, and it's a hurdle for adoption. There is the need for auditable processes, and companies and even researchers in the future probably need to have auditable results. How do you see this improving or increasing that gap?
Thank you very much for the point. I didn't mention anything around responsible AI. You're right. Everything around it. Also in terms of fairness, inclusivity. But something that will be much easier is to really detect papers that are not reporting accurate results. Much easier now. Also, another thing that is much easier is that when you look from our field to a paper, can I replicate that? So the type to try to verify a research output will be much easier. And if you look to the number of papers in the last half year, if you go Google it, that have been identified as false or as a non-true kind of papers, has going up dramatically. So this is something that AI, from a positive side, will help us to distinguish these two things. The auditable AI in a lot of different scientific fields. For instance, if you look to biology, biomedical engineering, medicine, and so on, it was mandatory, still is mandatory, to have the logbook, right? Paper is still paper-based. So everything that you have in experiment A or B, so in a lot of different fields, the being auditable was already a must. So it's not related to this AI Act. The AI Act actually is not so much into our field, but actually it's when you have very risky applications, as you know, and the type of risk. So you try to anticipate the risk of the application, and then you design or you derive the set of actions that you should follow based on the risk of a certain application, which is interesting about the AI Act. Actually, I was in the preliminary conversations of AI Act. They started before 2022, right? They started before generative AI and so on. So my point is that, and now the European Commission tried to reduce a lot the requirements and the constraints. So we don't know what will happen, because even this way of using LLMs will change dramatically in the future. We are not going to do any prompting soon. This prompting will be something from the past. Don't you believe that it seems like very old stuff? Depending on how good you are doing prompting, the output is different. I think it's something. It will change completely. We're not going to do any prompting in the future. So all of a sudden, without prompting, can we still do auditing on that? But so in another way, can it be? Do you agree in ethical by design in this AI world or not? Even if we try to do that, I think that things will go in such pace that we should have downstream very efficient and effective ways of identifying out deviations or non-conformities, and so on and so forth. But it's important point.
Thank you. I think let's thank.
Thank you very much. Thank you for.
And thank you for coming.
No, it is a pleasure. Thank you very much.
Just something. So let's think again. I will make some announcements. More announcements for the today. Where is the mouse? So the lunch today is the same place of yesterday. Okay. Oops. So the network, the public buses. So the